Hi, welcome to this video on prime factorization. Basically, what prime factorization is when we write a number as the product of its primes. To do this, we first need to have a list of the prime numbers in ascending orders. For our purposes, the first few prime number would do. The first few prime numbers are 2. It would be better if I For our purposes, the first few prime numbers are 2, 3, 5, 7, 11, 13, and so on. The list is infinite, but for our purposes, this will do. Now, most numbers can be written as a product of 2 or more smaller numbers. For example, 36 can be written as either 4 times 9, or can be 3 times 12, or can be 6 times 6, and some other perhaps. But there are some numbers that you cannot write as a product of 2 smaller numbers, like these ones in red up here. These are called primes. A prime number, in other words, is divisible either by itself or 1. So 5 can be written only as 1 times 5. There is no other way to write this. Now, with this preliminary behind us, we're going to start looking at how we factorize a number into the product of its primes. Let's take, for example, the number 24. The technique I use here is quite old school, but it always works and it's quite elegant. I think different coaches use different techniques. They use tree diagrams, etc., but this is my preferred method. So the way we do this, we look at the number, we start from the smallest prime, which is 2. We ask, is this number divisible by 2? Now 24 is an even number. It is divisible by 2. So we write 2 here, and we do the process of division. 24 divided by 2 is 12. We continue. Is 12 divisible by 2? It is. So we write 2. 12 divided by 2 is 6. Is 6 divisible by 2? It is. 6 divided by 2 is 3. Is 3 divisible by 2? It isn't. We move to the next prime. Is 3 divisible by 3? It is. We get 1. And when we get to 1, here in the left-hand column, we stop. And we write 24 is equal to 2 times 2 times 2 times 3. And these are the prime factors of 24. It's always beneficial to be able to write this in index notation, which in this case 24 would be 2 to the power 3 times 3, which is 8 times 3, which is 24. Okay, we will do another example. For our second example, let's look at the number 36. Again, what I'll do, I'll draw a vertical line next to it. Start with the smallest prime. Is 36 divisible by 2? It is, because it's an even number. 36 divided by 2 is 18. Is 18 divisible by 2? It is. It's an even number. 18 divided by 2 is 9. Is 9 divisible by 2? It is not. So we go to the next one. 9 is divisible by 3. The answer is 3. Is 3 divisible by 3? It is. The answer is 1, and we stop. So 36 can be written as 2 times 2 times 3 times 3. And these are the prime factors of 36, which in index notation is 2 to the power 2 times 3 to the power 2. Next number we try is 45. You notice that this is not an even number, so it won't have a factor of 2. So we start. Is 45 divisible by 2? It is not. We move to the next one. Next prime is 3. 4 and 5 are 9. So this is divisible by 3. So I write 3 here. 45 divided by 3 is 15. Is 15 divisible by 3? It is, because it's 3 5. So divisible by 3, it gives me 5. Is 5 divisible by 3? It is not. I move to the next prime, which is 5. So 5 divided by 5 is 1. So 45 can be written as 3 to the power 2 times 5. So 3, 3, and 5 are the prime factors of 45. For our last number, we'll try 150. It's a slightly larger number, but the size really is immaterial. As long as we can do the divisions, we can do this for any number. So is 150 divisible by 2? It is, because it's an even number. So 150 divided by 2 is 75. Is 75 divisible by 2? It isn't. But 7 and 5 are 12 is divisible by 3, so it can be divided by 3. So 75 divided by 3 gives 25. 25 is not divisible by 3, so we move up to the next prime. It's divisible by 5, so 25 divisible by 5 is 5, and 5 is divisible by 5, gives 1, and we stop here. So 150 can be written as 2 times 3 times 5 to the power 2. So 150 is 2 times 3 times 5 to the power 2. That means 2, 3, 5, and 5 are the prime factors of 150. I hope you find this video useful. In another video, I have shown how we use prime factorization to find the highest common factor and the lowest common multiple of 2 or more numbers. If you like this video, give it a like and click on the subscribe button.